All right. I got this book off of archives.org. It's a French and Wilson Code for Conducting Steam Locomotive Tests, Railway Mechanical Engineering, BS 1914. University of Illinois Library, 1914. Let me back out of this. All right, Code for Conducting Steam Locomotive Tests by Henry Helm French and James Aiken Wilson. Thesis for degree of Bachelor of Science in Railway Mechanical Engineering, College of Engineering, University of Illinois, 2017. This certifies that this has been prepared under my supervision, James Aiken Wilson, Henry H. M. France, entitled Code for Conducting Steam Locomotive Tests, is approved by fulfilling part of the requirements for the degree. The Bachelor of Railway Mechanical Engineering, and then instructor in charge, approved, head of Department Railway Engineering. All right, Code for Conducting Steam Locomotive Tests. Introduction, purpose, introductory statement, acknowledgments. Part 1, general instruction preparation indicator, reducing motion, sample of coal and gas, stack and exhaust pressure, heating surface standards, fuel records report, laboratory tests, object preparation and fuel, ash and refuse, sampling of coal, analysis of coal apparatus, instruments, application of instruments, operation conditions, duration tests, starting, stopping, records, data, and results, road tests, object, apparatus, instruments, preparation to be made in the shop previous to the run, determinations to be made immediately previous to the run, stopping and running, records of tests, data, results, summary of Part 2, appendixes, number 1, apparatus, instrument, location of, number 2, ash and cylinder analysis, number 3, brakes, number 4, calculation of methods, number 5, calibration of apparatus instruments, number 6, calometers, number 7, clearance and determination, number 8, coal size, number 9, dynometers, number 10, fuel analysis, number 11, gas sample analysis, fuel gas. Number 12, gauges, pressure, draft gauges. Number 12, indicators. Number 14, instruction sheet, individuals. Number 15, leakage test. Number 16, log sheets. Number 17, plant. Number 18, pyrometers. Number 19, road test, fuel and water measurements. Number 20, smoke determination. Number 21, speed indicators and stroke counters. Number 22, steam loss measurement of. Number 13, thermometers. Number 23, thermometers. All right, code for conducting steam locomotive tests. The purpose of the locomotive test is primarily to promote uniformity test method and data collected with the calculation of the result of the final representation of the report of the test in order that the test results may be in the greatest value, the highly desirable that they may be complete and accurate in such a form as easily available in comparison with the results of the other tests. Accomplish these purposes to make the code of the greatest usefulness and the aims to present full declaration of the time preparation actual conducting locomotive tests and for the calculation tabulation of the results, which show clearly and concisely the more important striking features over the performance of the locomotive, to give the directions in such a detail that the men cooperatively are familiar with the work and will be able to carry such tests and calculations without reference to source of information not mentioned in the code. That are different to obtain. Introductory statement. The code presented is divided into two main divisions. Part 1, consisting of general instructions, laboratory tests, and road tests, compromises the code proper and should be followed exactly in as far as the follow to all. Part 2 consists of the appendixes and presenting description, instruments, method of location, calibration, precautions, method of calculations, etc. Part 2 should be used as a guide to aid the carrying of the work outline. In Part 1, acknowledgments, various sources of information have been freely drawn with referred to, including standard text books and recent publications relating from publication of the locomotive tests and allied subjects, in particular with the proceeding of the American Society of Mechanical Engineers. A proposed locomotive testing could be the American Railway Master Mechanics Association and St. Louis testing conducted with the Pennsylvania Railroad Company have been freely used source information. All right, Part 1, General Instruction. All methods determining the data of the instrument used, their location, calibration, etc. should be such that the data and results may accurately represent the conditions under investigation. Appendixes 1 through 23 should be referred to in instruction relating to the type of the instrument, method of mounting, calibration. Preparation and preparing the test, therefore, 4 main items should be considered: locomotive dimension, examination of the plant and equipment, apparatus, and instrument, and in precautions against leakage, measurement of the dimension of the principal parts of the locomotive to be tested so far as they bear on the data required should be determined from the locomotive direct measurement and the correct working drawing. The general feature of the locomotive should be noted with both exterior and interior sketches mode if needed to show the unusual points of the design. A thoroughly examination of physical condition of the parts of the plant locomotive equipment should be made. The conditions found recorded together with any of the points of the matter operation with the bear upon them. Care should be taken that there is no leakage of any other parts of the locomotive parts or any other steam or water connections of the plant and apparatus which would be in any way affect the results. The arrangement of locomotion testing appliances must be left in a certain extent of the judgment and ingenuity of the engineer in charge. The object of the test will be in large measure determine the conditions, apparatus, locomotive equipment, and one of the guiding the rules. However, we should always keep in mind the visa and see that the apparatus instrument are reliable to arrange them in such a way that secure correct data. A list of most important apparatus and instruments given below. The directions concerning their mounting, operation, calibration, etc. will be found in the appendix. Platform scales of coal and ash, water weighing and measuring apparatus, pressure gauges, thermometers, barometers, pyrometers, drafter gears, steam calameters, gas apparatus, smoke determining apparatus, steam cylinder, indication of the reducing motion, planometers, tachometers, other speed measuring devices, dynamometers. All right, inductor reducing motion. The inductor reducing motion should be given the desired reductions in piston travel. The inductors have the little loss of motion as possible, and form of the reducing motion may be used in piston travel and accurate transmitted to the indicator in each of the case. Your sample in coal ash. The coals or sample should be taken in accordance with the instructions of the American Chemical Society. The gas should be taken as the same convenient location in the front end of the arrangement, and at such a point that will give the thoroughly represent some sample of the smoke box gas to be tested. Stock and exhaust pressure. Stock and exhaust pressure should be taken at such points will give result in representative of the pressure being measured. Heat surfaces. The heating surface should be computed with the fire side of such parts of the locomotive that transmitted heat with water and steam, and the general test report should be indicating clearly just what was included with the heating surfaces as reported. Standards. The steam table of the marks of Davidson should be using computing results from the test data. The standard units on which the various measures of capacity and the standard forms expressing efficiencies economy to which they could apply are as follows: one indicated horsepower developing into many cylinders. 2, 1 dynamometer horsepower delivered into the drawbar. 3 the pounds of the dry fuel per 8 IHP or hours limited. 4 the pounds of dry fuel per DHP hours. 5 pounds of dry steam per IHP hour. 6 pounds of dry steam per DHP hour. 7 pounds of water evaporated per 10 of dry coal. 8 pounds of dry fuel per 10 miles. 9. Boiler machine locomotive efficiency. Fuel. The fuel is used with the representative locality in which the locomotive is to be run for special tests is needed to apply. Need not apply. Records. A log of the data should be entered with notebooks with blank sheets suitable prepared in advance. They should be done in the same manner. The test may be divided into hourly period, necessary period of less duration, leading data obtained by any one of the more periods desired, thereby showing the degree of the uniformity obtained. The reading of the various instruments should be in general, making simultaneously at specified regular intervals. All right, your report. The report test should be represent all the leading factors which bearing on the design, dimension, condition, operation of the locomotive tested, and should induce the description of any apparatus auxiliary concern, and together with such sketches that may be needed to clearly understand all the points under consideration. It should be clearly that the objective characteristic of the test and the method followed with the conditions of the maintained with the conclusion or each closing the tabular summary of the principal data results. All right, your object. The object of the laboratory test is to determine the steam and the coal consumption per unit with the power of the locomotive that operated under the fixed condition of the other less than prominent objects as such items as determined with the performance of the engine under the different conditions of the boiler with the different rates of combustion. When the object making a test is other than stated above, the modifications may be made of this code, but they should be in such a conform to clearly possible with the code of the permit, carrying out more important purposes of the code regarding uniformity, complexity, and accuracy. All right, preparation. All driving wheels should be turned to the same diameter and should be standard contour. Each pair of the drivers should be checked to determine that they are correctly quartered for the crank pins. If the locomotive selected with has ever been thoroughly through the shop, the general repairs of the frame should be tried to see if they line up with the cylinders. The boiler tubes must be newly placed as so to be free of the boiler sediment. The steam cylinder should be approximately with the same diameter of the packing rubbing surface of the good condition. On a slide valve with the type of the locomotive, the valve seat should be faced and on position valve with the bushings applied if they are not in good condition. Check over the front of the arrangement to see that agrees with the arrangement previously determined upon. The stacked draft pipe should be lined with determined that the properly erected the reference exhaust nozzle, the piston valve, the packaging ring should be examined in good condition after with the test pressure at least 60 pounds should be applied with the steam pipe to determine that the throttle and the steam pipe's exhaust passages are tight. Steam joint injector delivery pipes should be tested to determine that they are steam tight. The locomotive selected should be reached for locomotive testing laboratory and early enough prior to the time of which it's scheduled to undergo the test. This will allow the sufficient time for the application of the instrument, taking necessary measurements for various parts of the locomotive. The locomotive driving wheels should be centered carefully with the supporting wheels that give correct drawbar pull. The fuel. For efficient testing, the locomotive, the standard coal should be selected with easily obtained with the short notice and in accordance with the special object in view. The maximum efficiency of the capacity is desired. The coal should be preferably the same kind that is regarded as the standard with the locality where the locomotive is operated. When oil fuel is used, the rules of governing the test should be modified to conform characteristics of liquid fuel. Ashes and refuses. Ashes and all refuse withdrawn from the ash pan and smoke box stack cinder collector at the end of the test should be weighed in dry state. If desired, samples taken for the determination of heating value unburned carbon. Alright, sampling coal. If coal is to be tried more than the amount of the necessary to make the test, it should be sampled accordingly to recommendation for the Committee with the American Chemical Society. The sample should be given in general not less than 300 pounds. After it is crushed and quartered, and about 1 quart should be taken and placed in an airtight jar for a chemical analysis. Our analysis of coal. The analysis commonly made are when what are termed as approximate. The analysis that constitutes determination of the following items: the fixed carbon percent, the volume, volatile matter percent, the moisture hydroscopic percent, the moisture total percent, ash percent, sulfur determined and separated percent, BTU per pound of fuel, and for complete determination of the quality of the coal necessary for the ultimate analysis, which requires determination of the following additional types: carbon percent, hydrogen percent, nitrogen percent, oxygen by difference percent. Apparatus and instruments. The apparatus and instruments required for the laboratory test for the locomotive are as follows: platform scale weighing coal and ash, tanks and scales weighing water, graduated scale of measuring height and water, boiler for pressure gases in the boiler, branch pipe, receiver, the exhaust, and any other points are required. Draft gauges or smoke boxes, fire boxes, ash pan, thermometers, and for calorimeters. Branch pipe receivers, exhaust for room temperature on wet and dry bulb, thermometers, and hygrometers. 7. Pyrometers of the firebox, smoke box, at any of the other points or maybe as required. Steam calorimeters, steam cylinder indicators. Some of the speed recorders to denote the revolution of the driving wheels. Gas analysis apparatus, friction apparatus, dynamometer for determining the pull at drawbar. Indication reducing the motions. Smoke chart and other smoke measuring registering devices. Spark catcher. In addition to the above, it will be desirable to have planometers, micrometers, scales, and calculating instruments, etc. Alright, all instruments should be calibrated with the often as requirement for the corrections in accordance with the such calibration of the Boiler calibration determination of the amount of water being passed for the calorimeter. Safely valves and loss in the other ways should be made in for general directions relating to calibration. Appendix number 5. Or applications of instrument. The pressure gauge of the boiler and branch pipe exhaust should be suitable connected located with the point conveniently with the observe. For taking the temperature of the steam of the branch pipe exhaust package, thermometers should be inserted into the wells given proper depth of the immersion. The indicator reducing rule should be suitable for the transmitting of the reducing motion accurately for the indicator of the pipe loading with the cylinders. To be indicator should be suitable size so as to give free passage steam, or should be both connected in the same cylinders rather than into the heads, thus making a very short connection. Short bends in pipes should be avoided, and the end of the pipe should be well lagged to prevent radiation. A suitable framework should be secured with a cylinder as act to brace the indicator of the motion of the rod supports rigidity and high essential in this particular. Highly essential in this particular. Care should be taken with the indicators in such a position that the ring end of the end on the end of the motion rod travel the direction pointing with the groove of the drum proper. Draft gauges should be placed in convenient locations with suitable connections to the smoke box or other points in which the draft is to be taken. Flexible connections should generally be used. The sampling end of the draft tube should not be within several inches of the surface of their obstruction. In the smoke box of the draft pipes should be located with the horizontal center line of the boiler, front of the backing of the back of the diaphragm, and of the vertical center line of the boiler. In no case, however, there should be a draft observation and be unduly affected with the exhaust jet. The draft of the firebox should be taken with a suitable opening located with the point of the half of the length of the firebox, about 24 inches above the grates, provided with the point do not come too close to an arc of the other obstructions. The draft in the ash pan should be taken with at some convenient point about center to the entire grate area several inches below the grate. Alright, smoke box pyrometer thermometer should be inserted so that the hot point of the bulb will give the correct determination of the temperature of the gases being sampled for analysis. If the thermometer is used for this purpose, it should be graduated at 1,000 degrees. The tube placed in the firebox inserting with the pyrometer should be located opposite near the point of taking the draft. The gas sampling of the pipe should be located at such a point that the gas ensuing the different tubes with a thoroughly mixed end that they may not be diluted with exhaust steam. This generally across the center of gravity in the section just behind in front of the exhaust pipe and below the table plate. The sampling pipe should be plugged in at the end of the numerous drilled holes, especially equally spaced throughout its length. The total areas of the drilled holes should not be more than the inside area of the sampling gauge. Steam calorimeter should be attached either at the dome at the point of the cross the throttle valve of the branch pipe according as desired to obtain the character of the steam at one point of the other former location as preferred. Sample tube. The above-proved design should be used for the collection and sample of the steam of the calorimeter. Operation condition of laboratory test should be the maximum efficiency is objective in the view. This should be uniformly in such a manner that steam pressure and quantity of the coal applied to each firing thickness of the firing and any other firing operation. The rate of supplying the feed of water should be uniform throughout the entire test, and certain levels above the second gauge cock should be maintained and start the finishing test. Duration. The duration of laboratory tests for the locomotive will depend on the character of the fuel, the rate of the combustion, and of the work limitation of the result involving parts. The test should be run until 150 pounds of coal have burned per square foot of the grate, and if the rate of the combustion less than 50 pounds of coal per square foot grate per hour, the test should be continued at least 3 hours. Starting and stopping. Before starting a test, the fire should be cleaned by rocking the grate and running it at the test load condition, uniform condition, but that have been maintained. The state has been reached out of thickness with the fire and bed with the steam pressure of this water level of the locomotive at the time. The other readings should be taken with the time recorded as starting time. Immediate fire with the weighed coal and proceeding with the regular test. When the end of the test approaches, the fire should be brought as nearly possible in the conditions starting, particularly with regards to the unburned fuel in the firebox, taking a steam pressure water level and in time the record of the letter of the stopping time. If there's a difference between the steam pressure and water levels at starting and stopping, correcting should be applied. Alright, records. Log of data should be entered in the printed forms, but the records should be taken in 10 minutes or other suitable time intervals. The coal should be weighed out not less than 3,800 pounds of the lots and time taken with the last burn weight. Tanks of the efficient capacity should be provided with the maintained water and supply varying in a head of not more than 6 inches. Reading of the water consumed should be plotted upon the graphical logs and conventional regular intervals. Indicator diagrams should be in general be taken at the same time other than data are taken. Insufficient numbers of the observers should be supplied in order to all important observations be taken simultaneously. At a laboratory with 2 tests that are made each day, the number of men required is as follows. The director's test, 1. Foreman, computing room, 1. Computer and draftsman, 7. Stenographer, 1. Foreman, testing laboratory, 1. Brake wheel operator, 1. Cab observer, 1. Fuel observer, 2. 1. Water observer, 1. Indicator observer, 2. General observers, 2. Engine operator, 1. Fireman, 1. Fireman, 1. Chemist, smoke observer, 1. Gas sampler, 1. Assistant foreman, testing laboratory, 1. Mechanics, 2. Coilers, 2. And coal pressure, 3. When the tests are not run daily, some of the observers might utilize the computers, vice versa, and the total number of them not employed considerably decrease. In special cases, as when a mallet type of the engines are tested, additional observers may be required. Alright, here, data results, description, dimensions, and portions. Driving wheels, number of pairs, number of diameter in inches, measured circumference in feet, and right, number 1 through 8, and then measured circumference in feet, and left, number 1 through 8. Average circumstances, feet, 19, 20, average diameter inches. Engine truck wheels, number 26, number 27, diameter inches. Trailing wheels, number 33, diameter in inches. Wheelbase, driving 39, driving wheelbase front locomotive in feet. Driving wheelbase, number 40, driving wheelbase for rear locomotive in feet. 41, total wheelbase in feet. 42, gauge wheelbase in inches. Weight of engine in pounds with the water at second gauge cock and a normal fire. 48 on truck, 49 first drivers, 50 second drivers, 51 third drivers, 52 fourth drivers, 53 fifth drivers, 54 sixth drivers, 55 seventh drivers, 56 eighth drivers, 57 on trailers, 63 total, and 64 total on drivers. Cylinders. 65 high pressure number, 66 low pressure number, 67 arrangement, 68 diameter inches high pressure and right. 69 diameter inches high pressure left, diameter in inches low pressure right, 71 diameter inches low pressure left. Stroke of piston in inches, 77 high pressure right, 78 high pressure left, 79 low pressure right, 80 low pressure left. Clearance percent of the piston displacement. 86 high pressure right head end, 87 high pressure right crank end, 88 high pressure left end head end, 89 high pressure left crank end. Low clearance percent piston displacement, 90 low pressure right head end, 91 low pressure right crank end, 92 low pressure left head end, 93 low pressure left crank end. Receiver in cubic feet, 99 volume right side, 100 volume left side. Alright, steam portions, inches. High pressure administration right head end, length and width, 106 and 107, 108 108 and 109. High pressure administration right crank end, left length and width, 110 and 111. High pressure left end, head end, length and width, and then high pressure 11, 12, and 11, 13. High pressure left crank end, length and width. 114 low pressure emissions, right head end, length and width, that's 14 and 15, 116, 117 low pressure end, right crank end, length and width. 118 low pressure emission, left head end, length and width. 118 and 19, 120 through 121 low pressure emission, left crank end, length and width. 122, 123 high pressure exhaust, right and length, width. 124 and 125 high pressure exhaust, left and length and width. 26 through 27 low pressure exhaust, right and length and width. 28 and 29 low pressure exhaust, left, length and width. Piston rod diameter inches. High pressure right, high pressure left. That's 135 and 136. 137 low pressure right. 138 low pressure left. Tail rod diameters. High pressure right, high pressure left. 144 and 145. 146 and 147 low pressure right and low pressure left. Valves type 153, 154 design, 155 balance area and percent of the total, 155 type and link motion. Greatest valve travel in inches. High pressure right, 162. High pressure left, 163. 164 low pressure right, 165 low pressure left. All right, outside lap of the valve inches, 172. 171 and 172 low left high pressure right head end and crank end. 173 high pressure left head end. 174 high pressure left crank end. 175 low pressure right end head end. 176 low pressure right crank end. 177 low pressure left head end. 178 low pressure left hand crank end. Inside lap valves in inches, high pressure right head end, 184, 185 high pressure right crank end, 186 high pressure left head end, 187 high pressure left crank end, 188 low pressure right head end, 189 low pressure right crank end, 190 low pressure left head end, 191 low pressure left crank end. Miscellaneous 197 cylinder lagging material, 198 cylinder jacket material, boiler type 204, 205 outside diameter first ring in inches. Tubes 211 number, 212 outside diameter inches, 213 thickness inside, 214 length between the tube sheets inches, 215 tube fire area square feet, 216 serve tubes number of ribs, 217 serve tubes square inches and inside dot surface and 1 inch of length. All right, your superheater type, 223, 224 number of tubes, 225 outside diameter in inches, 226 inside diameter inches, 227 length of tubes in inches, 228 seam area through the units in square inches. Firebox inside length in inches, 235 width in inches, 236 depth from the end inches, 237 depth from back to end inches, 238 volume cubic feet. Fire doors 244 number, 245 area square feet. Grates 251 style, 252 total area square feet, 253 total area dead grates square feet, 254 width of the airspace in inches. Are your air inlets through the firebox in square feet, 261 through the gates in square feet, 262 through the fire door in square feet, 263 total air inlets at number 260 and number 261 and number 262 square feet, 264 rare air inlets at number 261 to the gray area to number 252, and 265 ratio and inlets at number 263 to the gray number 252. All right, heating surface in square feet, 271 out of the tubes of water side, 272 out of the tubes of the fire side, 273 out of the firebox side, 274 out of the superheater fire side, 275 total based on the inside firebox and inside of the tubes, 276 total based on the inside of the firebox and outside of the tubes. Boiler volumes, 282 water space to cubic feet, 283 steam space in cubic feet. All right, exhaust nozzles, 289 type, 290 dimension right side inches, 291 dimension left side in inches, 292 area of the right side in square inches, 293 area of the left side in square inches, 294 total area. Reverse lever, 300 high pressure cylinder notches forward on the center, 301 low pressure cylinder notches forward on the center. Ratio, 307 heat surfacing number 275 of the grate area, number 252, 308 fire area through the tubes, number 215 through the gray area, number 252, 309 firebox heating surface number 273 to the gray area, number 252. 310 tube service number 272, the firebox heating of the surface is number 273, 312 superheating length of the units is number 227 to the internal diameter number 226, 31 firebox volume the number 238 to the gray area number 225. E-actors for the dynamometer horsepower power developed when the speed is over 1 RPM. The pole is 1 pound. For indication of horsepower power developed at RPMs at 1 pound and 1 MEP. All right, 319 high pressure inner cylinder right head end, 320 high pressure inner cylinder right crank end, 321 high pressure cylinder left head end, 322 high pressure cylinder left crank end, 323 low pressure cylinder right head end, 324 low pressure cylinder right crank end, 325 low pressure cylinder left head end, 326 low pressure cylinder left crank end. For piston displacement in cubic feet, high pressure cylinder right head end, 332, 333 high pressure cylinder right crank end, 334 high pressure cylinder left head end, 335 high pressure cylinder left crank end, 336 low pressure cylinder right head end, 337 low pressure cylinder right crank end, 338 low pressure cylinder left head end, 338 low pressure cylinder left crank end. Observed data 345 duration of test in hours. Speed 351 total revolution, 352 average per minute, 353 equivalent speed in miles per hour, 354 equivalent piston speed in feet per minute. All right, piston of levers. 360 reverse lever notches from the front end, 363 throttle lever temperature degrees in Fahrenheit, 366 of the smoke box by the thermometer, 367 smoke box by the pyrometer, 368 laboratory by dry bulb, 369 laboratory by wet bulb, 370 steam of the branch pipe, 371 steam of the reverser, 372 steam of the exhaust pad, 373 of feed water, 374 of firebox and pyrometer. Pressure pound per square inch in boiler average and 380, 381 boiler maximum, 382 boiler minimum, 383 in branch pipe, 384 in HP cylinder, 385 in LP cylinder, 386 in receiver, 387 exhaust passages, 388 laboratory barometrics. Drafting in inches of water, 394 in smoke box front diaphragm, 395 in smoke box back diaphragm. 396 in firebox, 397 in ash pan injectors, 403 total right, 404 total left, 405 number of times on the right, 406 number of times on the left. Quality of steam, 407 in the dome, 408 in the branch, 409 degrees of superheated in the branch pipe, 410 degrees of superheated in the receiver, 411 degrees of superheated in the exhaust, 412 factor correction of the qualifying quality of the steam. Coal, spark, and ash, 417 coal fire kindled, 418 coal fire total, 419 dry coal fire total pounds, 420 combustible analysis total, 421 analysis and analyst total, 422 cylinders collected in the smoke box total, 423 sparks discharged with the stack of the total, 424 cylinder spark in total, 425 coal loss due to the steam loss pounds per hour. Smoke, 431 Ringel man chart percent, fourth analysis of coal approximated, 437 fixed carbon, 438 volatile matter, 439 moisture hydroscopic, 431 ash, and that was all in percent. 442 sulfur determining separately percent, and 443 BTUs per pound of fuel. Analysis of coal ultimately, 449 carbon percent, 450 hydrogen percent, 451 nitrogen percent, 441 ash percent, 442 sulfur percent, 452 oxygen difference in percent. Alright, calorific value in BTUs per pound, 458 of dry coal, 459 of combustible, 450 of cylinder and sparks, 461 of ash. Analysis of smoke box and gases, oxygen, O%, carbon monoxide, CO percent, carbon dioxide, CO2 percent, nitrogen percent, and hydrogen, H percent. Water in pounds delivered in injectors, 476, 447, lost from the boilers, 478, lost from 479, 479, lost from 480 lost total, 481 delivered from the boiler and presumable evaporated, dynamometer fuels in pull in pounds, 47 average, 488 minimum, 489 minimum. Alright, cutoff percent stroke, 495 high pressure cylinder right head end, 497 high pressure cylinder right hand crank end, 497 high pressure cylinder left head end, 498 high pressure cylinder left crank end, 499 averages, 500 low pressure cylinder right head end, 501 low pressure cylinder right crank end, 502 low pressure cylinder left head end, 503 low pressure cylinder left crank end, 504 average. Release percent of stroke. High pressure cylinder right head end 511. High pressure cylinder right crank end 512. High pressure cylinder left head end 512. High pressure cylinder left crank end 514 average. 515 low pressure cylinder right head end 516 low pressure cylinder right crank end 517 low pressure cylinder left head end 518 low pressure cylinder left head crank end 519 average. Alright, beginning with the compression percent of the stroke, the high pressure cylinder right head end, the 525, 526 high pressure cylinder right crank end, 527 high pressure cylinder left head end, 528 high pressure cylinder left crank end, 529 average, 530 average pressure cylinder right head end, 531 low pressure right crank end, 532 low pressure left hand head end, 533 low pressure left crank end. Average 534 average. Pressure from the indicator indicator cards, initial pressure pounds per square inch. High pressure cylinder right head end 541. High pressure cylinder right crank end 542. High pressure on the left head end 543. High pressure on the left head crank end. Average 554. High 545. Low pressure cylinder right head end 546. Low pressure right crank end 547. Low pressure cylinder left head crank end 548. Low pressure cylinder left crank end 549 average. Steam chest pressure pounds per square inch. High pressure right side 555, 556 high pressure left side, 557 low average, 558 low pressure right side, and 559 low pressure left side, 560 average. Alright, pressure and cutoff pounds per square inch. High pressure cylinder right head end, 5 pressure cylinder right crank end, high pressure 568 high pressure cylinder left hand end, 569 high pressure cylinder left crank end, 570 average, 571 low pressure cylinder right head end, 572 for low pressure cylinder right crank end, 573 low pressure cylinder left hand end, 574 low pressure cylinder left crank end, 575 average. Pressure at release of pound square inches, 581 high pressure cylinder right head end, 582 high pressure on the left right crank end, 583 high pressure on the cylinder left head end, 584 high pressure left crank end, 585 average, 586 low pressure on the cylinder right head end, 587 low pressure cylinder right crank end, 588 low pressure right head end, 589 low pressure cylinder left crank end, 590 average. Pressure at the beginning of the compression, pounds per square inch. High pressure cylinder right head end, high pressure cylinder right crank end, high pressure cylinder left head end, 5 high pressure cylinder left crank end, 600 average. Low pressure cylinder right head end 601, low pressure cylinder right crank end 602, low pressure cylinder left head end 603, low pressure cylinder end crank end 604, 605 average. Or at least back pressure pounds per square inch. 611 high pressure cylinder right head end, 612 high pressure cylinder right crank end, 613 high pressure cylinder left head end, 614 high pressure cylinder left crank end, 614 average, 616 low pressure cylinder right head end, 617 low pressure cylinder right crank end, 619 low pressure cylinder left head end, 619 low pressure cylinder left crank end, and 620 average. Alright, summary of average results. 626 dry coal fired per hour pounds, 627 dry coal fired per square feet, a great surface. Evaporation in pounds, moist steam per minute and per hour, 634 dry steam per hour, 635 dry steam per hour per square foot of the heating surface, 636 dry steam per pound of the dry coal, 637 dry steam pound per fuel as fired, 638 steam with the loss of the calorimeter, safety valves, air pumps, and etc. per hour, 639 moist steam to the engines per hour, 640 factor of evaporation, 641 correction of heat storage and boiler, 642 dry steam of the engines per hour, 643 corrected water evaporated with the boiler per hour, 644 ratio of the heat from the boiler to the engines, heat from the fire to the boiler. Equivalent evaporation from and at 212 degrees Fahrenheit, 645 per hour, 646 per hour boiler excluding superheater, 647 per hour superheater alone, 648 per hour per square foot total heating surface, 649 per hour per square foot total heating surface excluding superheater, 655 per hour per square foot total heating surface superheater alone, 656 per hour per square grade area. 657 pounds per coal as fired, 658 pounds per dry coal, 659 pounds per combustible, 660 boiler horsepower, 666 efficient boiler based on fuel, 667 efficient boiler on per square feet of heating surface, 668 efficiency boiler per square and gray area. Summary of average results: engines not mean effective pressure pounds per square inch. 674 high pressure cylinder right head end. 675 high pressure cylinder right crank end. 676 high pressure cylinder left head end. 677 high pressure cylinder left crank end. 678 of average. 679 low pressure cylinder right head end. 680 high pressure right hand crank end. High low pressure cylinder left head end. 681 low pressure cylinder left crank end. 682 683 average. Receiver 689 pressure right side, 690 pressure left side, 691 average. Number of expansions: 697 right side head end, 698 right side crank end, 699 left side head end, 700 left side crank end, 701 total. Indicating horsepower: 707 high pressure cylinder right head end, 708 high pressure cylinder right crank end, 709 high pressure cylinder left head end, 710 high pressure cylinder left crank end, 711 total local pressure cylinder right head end, low pressure cylinder right crank end, 12 and 13, 714 and 715 low pressure cylinder left hand crank head end and crank end, and 716 total. Our divisions of power: 722 high pressure cylinder right side, 723 high pressure cylinder left side, 724 low pressure cylinder right side, 725 low pressure cylinder left side, 726 the right side total, 727 left side total, 728 total. Alright, per IHP per hour: dry coal per pound 734, 735 BTU in full fuel, 736 dry steam in pounds, 737 BTU in steam. Some of the average results: 743 dynometer horsepower, 744 dry coal DHP per hour pounds, 745 dry steam DHP per pounds an hour. BTUs per DHP per hour in pounds: 752 dry coal per 1 million foot pounds at drawbar, dry steam per 1 million foot of pounds at drawbar, BTU per 1 million foot pounds at drawbar, IHP per square foot of heating surface, IHP per square feet of grating surface, DHP per square of heating surface, DHP per square of grate surface. Traction power based on the MEP pounds. Alright, machine friction locomotive in terms of horsepower: 770, 771 MEP powers, 772 drawbar pull pounds. Efficiency: 778 efficiency, machine efficiency of locomotive percent, 779 the thermal efficiency of locomotive based on the fuel percent. Ratio: 785 total weight of locomotive maximized IHP, 787 total heating surface of maximum IHP, 792 test numbers, and also summarized statement of average testing results. 792 test number, 345 duration of testing hours, 352 number of revolutions per minute, 353 speed in miles per hour, 363 throttle opening full or partial, 499 actual cutoff of percent of the horsepower cylinder, the high pressure cylinder actual cutoff of the percent of the low pressure cylinder. 294 air exhaust nozzle square inches, 380 boiler pressure pounds per square inch, 383 branch pipe pressure pounds per square inch, 386 receiver pressure pounds per square inch, and 387 exhaust pressure pounds per square inch. Alright, 615 average least back pressure in the IB HP cylinder, average least back pressure in pounds of the IP cylinders, 3409 super heat and branch pipe, 410 super heat and receiver, 411 super heat and exhaust, 394 draft in the front of the diaphragm, inches in water, 394 draft in the back of the diaphragm in inches in water, 396 draft in the firebox, inches of water, 397 draft in ash pan, inches of the water, 458 calorific value of the dry fuel, the BTU per pound, 626 dry fuel fire per hour pounds, 627 dry fuel per hour per square feet of the grate, 633 water delivered in the boiler pounds per hour. .645 equivalent evaporation from end to end at 212 degrees in pounds per hour. .648 equivalent evaporation from end at the 212 degrees pounds per square foot at firing heating surface. 658 equivalent evaporation from the net 212 degrees pounds per pound of dry fuel. 660 is boiler horsepower 34 U or E. 3666 efficiency of boiler based on the fuel. 431 average smoke percent. 642 dry steam to the engine in pounds per hour. 728 indicated horsepower. 734 dry fuel per IHP horsepower pounds. 736 dry steam per IHP horsepower in pounds. 487 draw power pounds. Drawbar pull pounds. 743 dynamometer of the drawbar horsepower. 744 dry fuel of the DHP power in pounds. 745 dry steam in the DHP hours. 778 machine efficiency of locomotive percent. 779 thermal efficiency of locomotive based on fuel percent. Alright, road test.